Jai Hind everyone, I am from Indian Space Team, PR Department. Imagine a time 4.5 billion years ago when Mars, the red planet, was just starting to form. A swirling, chaotic cloud of dust and gas surrounded our young sun, setting the stage for our solar system's formation. This was a time of intense cosmic activity, of grand celestial ballet, where particles danced, collided, and clumped together. This process, known as runaway accretion, would eventually give birth to our planets. Mars began as a tiny seed in this protoplanetary disk. Over time, it attracted more and more material, growing in size and mass. As it grew, its gravity became stronger, pulling in even larger chunks of rock and dust. This cosmic snowball effect continued for millions of years until Mars reached its present size, about half the diameter of Earth. But Mars is not just a smaller sibling of our planet. Its position in the solar system endowed it with distinctive chemical features. Elements with low boiling points, such as chlorine, phosphorus, and sulfur, are much more common on Mars than on Earth. These elements were probably pushed outward by the young sun's energetic solar wind. In the aftermath of planetary formation, the inner solar system was likely subjected to a period known as the Late Heavy Bombardment. About 60% of Mars's surface shows a record of impacts from this era, hinting at a turbulent and violent past. However, the existence of this bombardment period is hotly debated among scientists. Despite its tumultuous beginnings, Mars evolved into a world with a character all its own. Its rust-red surface, the result of iron oxide dust, earned it the nickname the Red Planet. Its thin atmosphere, primarily composed of carbon dioxide, and its two small moons, Phobos and Deimos, further distinguish it within our solar system. Thus, from a chaotic cloud of dust and gas, the red planet took shape. The birth of Mars is a tale of cosmic forces, of dust and gas, gravity and time, painting a vivid picture of the dynamic processes that shape our solar system. As Mars evolved, it experienced a period of heavy bombardment, forever changing its face. This period, known as the Late Heavy Bombardment, was a phase in our solar system's history when many of the planets, including Mars, were subjected to a high number of asteroid impacts. This occurred roughly 4 billion years ago, and the marks of these cosmic collisions are still visible today. Imagine a time when the calm of space was punctuated by the chaos of asteroids hurtling towards Mars, each impact reshaping the planet's surface, creating craters and valleys. These celestial collisions were so powerful that they could have caused Mars to wobble on its axis or even shift its position in the solar system. About 60% of Mars's surface bears the scars of this era. If you were to walk on the surface of Mars today, every step you took would likely be on ground that was once reshaped by these cosmic collisions. These impacts were not just surface deep, they sent shockwaves through the planet, causing Marsquakes and possibly even leading to volcanic activity. But these impacts did more than just reshape the surface of Mars. They also played a crucial role in the planet's evolution. The energy from these impacts could have melted Mars's icy crust, creating temporary lakes or seas. These bodies of water might have hosted the ingredients necessary for life, providing a brief window for life to potentially emerge. The Late Heavy Bombardment was more than just a period of destruction. It was a time of creation and transformation. It helped shape Mars into the planet we recognize today, with its distinctive red surface, towering volcanoes, and deep valleys. The early years of Mars were indeed tumultuous, shaping the planet we see today. As we continue to explore Mars, we will undoubtedly uncover more about this fascinating period in the planet's history, helping us to understand not just Mars, but our own planet as well. In the grand tapestry of our solar system's history, the early years of Mars are a chapter full of action, transformation, and mystery. From a planet scarred by impacts, Mars transformed into a geologically active world. This transformation unfolded across three major geological periods: the Noachian, Hesperian, and Amazonian periods, each with its own distinctive landscapes and events. The Noachian period, dating from about 4.5 to 3.5 billion years ago, bore witness to Mars's youthful tumult. The surface of Mars was blighted by meteor impacts, carving valleys and causing widespread erosion. Possibly the most intriguing aspect of this period, however, is the speculated presence of vast water oceans. Imagine, if you will, a Mars not of red dust and rock, but of blue seas and white-capped waves. Transitioning into the Hesperian period, roughly 3.5 to between 3.3 and 2.9 billion years ago, Mars became a cauldron of volcanic activity. This led to the formation of some of the largest volcanoes in our solar system, such as Olympus Mons, towering at an astonishing 13.6 miles high. Flooding during this period also carved out immense outflow channels, shaping the Martian landscape in dramatic ways. Finally, we reach the Amazonian period, which continues to the present day. During this time, the wind became a dominant influence on geological processes, sculpting the surface into a myriad of intricate patterns. Underneath the surface, Marsquakes tremble, reminding us that Mars remains a geologically active world. Throughout these periods, Mars transformed from a planet scarred by impacts to a world of volcanic vigor and vast oceans, and finally to the wind-carved, dust-swept landscape we see today. Each period contributed unique features, from towering volcanoes and deep valleys to the sweeping sand dunes and polar ice caps. These geological periods left Mars with a diverse and interesting landscape. A landscape that continues to captivate our curiosity, fuel our scientific pursuits, and inspire dreams of future exploration. Given Mars's geological history, one question has always intrigued us: could life exist on Mars? This question has fired human imagination and scientific curiosity for centuries. As we delve deeper into the history of the Red Planet, we find tantalizing hints that life, in some form, may have once called Mars home. About 4 billion years ago, Mars was a much different place than it is today. Its surface bore the marks of meteor impacts, valley formation, erosion, and possibly even vast water oceans. This was the Noachian period, a time when the conditions on Mars may have been conducive to life as we know it. From 3.5 billion to roughly 3 billion years ago, Mars entered the Hesperian period. This era was dominated by volcanic activity and flooding that carved out immense outflow channels. Could these channels have provided a habitat for primitive life forms? It's a possibility that continues to captivate scientists. Today, Mars is a cold, arid desert. Its thin atmosphere, composed mainly of carbon dioxide, offers little protection against the harsh radiation from the sun. Yet, life on Earth has proven to be incredibly resilient, adapting to survive in the most extreme conditions. Could similar adaptations have occurred on Mars? Or could life still exist there today, hidden beneath the surface or in pockets of water ice? These questions have spurred a flurry of exploration. Unmanned spacecraft and rovers have been sent to Mars, each carrying a suite of sophisticated instruments designed to search for signs of life. They probe the Martian soil, drill into rocks, and analyze the atmosphere, all in the hopes of finding evidence that life once existed, or perhaps still exists, on Mars. The possibility of life on Mars is more than just a captivating question. It's a scientific quest that could fundamentally reshape our understanding of life's place in the universe. It's a quest that drives us to explore, to seek, and to learn. The search for life on Mars continues to be one of our greatest scientific quests. Since the late 20th century, we've sent numerous spacecraft and rovers to explore Mars. This great endeavor began with the Mariner 4 probe, which in 1965 made the first successful flyby, sending back the first close-up images of the Martian surface. Then, in 1971, the Mars 2 probe made history as the first Mars orbiter, circling the planet and providing us with unprecedented views of its terrain. The exploration didn't stop there. In 1976, the Viking 1 probe made the first successful landing on Mars. It spent over 6 years exploring the Martian surface, sending back invaluable data that greatly advanced our understanding of the Red Planet. Since then, many other successful missions have followed, each one broadening our knowledge and igniting our curiosity. Fast forward to today, and Mars is far from lonely. As of 2023, there are at least 11 active probes either orbiting Mars or exploring its surface. Each of these probes is a testament to human ingenuity and our relentless pursuit of knowledge. They continue to send back data, helping us to understand the planet's geology, climate, and potential for life. But the exploration of Mars is not just about understanding the planet itself. It's also about us, about our place in the universe, and about our future as a species. Mars represents a potential new home for humanity, a place where we could one day establish a permanent presence beyond Earth. That's why Mars is such an attractive target for future human exploration missions. Though no such mission is planned in the current decade, the idea continues to inspire scientists, engineers, and dreamers around the world. As we continue to explore Mars, we move closer to the dream of one day setting foot on the Red Planet. Each rover that rolls across its surface, each probe that orbits above, brings us one step closer to that dream. And who knows, maybe one day, the footprints of those rovers will be joined by the footprints of humans. Please share this video